Hey everyone, and welcome back for another deep dive. Today, we are heading straight to Mercury.
Okay.
You know that little planet that zips around closest to the sun? The JAXA BepiColombo mission just did its 6th flyby, snapping some pretty incredible pictures before it settles into orbit in 2026.
Wow.
And these aren't just your average space snapshots. We're talking about the possibility of water ice hiding in shadowy craters and volcanic plains that just scream about Mercury's wild past.
You're absolutely right. This flyby is giving us such an amazing sneak peek at the incredible geology and history of a planet we're really only beginning to understand.
Okay, so I'm already hooked. I know you've been glued to these images.
Oh, yeah.
What are some of the things that have you most excited?
Well, one of the things that is just mind-blowing to me is the possibility of water ice in those craters at Mercury's North Pole.
What?
I mean, think about it. Water ice on the planet closest to the sun. It's like finding a snowball in a furnace.
Okay, so I'm picturing Mercury as this scorching hot world.
Yeah.
How could ice even exist there? Wouldn't it just instantly vaporize?
It's all about location, location, location. These craters are special because they're permanently shadowed. The sun never actually reaches their floors, making them some of the coldest spots in our solar system.
So even though Mercury's basically baking in the sun,
Yeah,
these craters are like little cosmic freezers.
exactly. And there's already some evidence suggesting that water ice might be hiding there. And BepiColombo will be able to get a much closer look once it's in orbit.
That is incredible. We've got potential ice on a planet that's practically touching the sun. But these images aren't just about frozen surprises, are they? What about those vast volcanic plains we're seeing?
Ah, yes, the Borealis Planitia. It's a sight to behold. It is Mercury's largest expanse of smooth plains.
Yeah.
It was formed by massive lava flows billions of years ago. It covers a huge portion of Mercury's northern hemisphere. It's like a giant solidified lava ocean.
Wow, I'm looking at the image now, and it's really hard to wrap my head around the scale of it. I mean, were these lava flows like slow oozing rivers or something more like sudden and explosive?
Think of it more like massive floods of molten rock, just engulfing the landscape. You can even see craters, like Henri and Lismore, that were partially submerged by these flows. Gives you a sense of just how powerful these events were.
Whoa. It's almost like looking at a snapshot of an apocalyptic event, frozen in time. And I'm noticing these weird wrinkles on the plains. What's the deal with those? Do they have anything to do with the lava?
Actually, those wrinkles are more like stretch marks from the planet itself shrinking. As Mercury's interior cooled over billions of years, it contracted, causing the surface to buckle and fold. Imagine a grape slowly turning into a raisin. It's kind of like that.
So these wrinkles are like a record of Mercury's aging process, and those volcanic plains tell us just how active this little planet once was. It really makes you appreciate that even seemingly quiet planets have really dramatic pasts.
You got it. And speaking of dramatic events, we can't forget about the Caloris Basin, one of the most striking features on Mercury.
Ah, yes. The granddaddy of all impact craters. From what I understand, it is absolutely colossal.
You're not kidding. The Caloris Basin spans over 1,500 kilometers. It's one of the largest impact basins in our entire solar system, formed when a massive object slammed into Mercury billions of years ago.
Okay, I'm officially trying to imagine the sheer force involved in something like that. The images show these radiating troughs emanating from the basin, and they're just massive. What caused those?
Those troughs are a direct result of the impact. Imagine shock waves rippling through Mercury's crust, fracturing and deforming the surface for thousands of kilometers. Those troughs are the scars left behind by that incredible release of energy.
Wow, it's like looking at the aftermath of a planetary earthquake,
Yeah.
but within this massive impact zone. There's a feature that really caught my eye. It's this bright boomerang-shaped lava flow. What's the story there?
That's a great observation. It's a fascinating mystery. Scientists are still debating whether this lava flowed into the basin after the impact, filling in the depression, or if it erupted from within the basin and flowed outward. It's kind of like a cosmic whodunit with lava as the main suspect.
So did the lava flow into the Caloris Basin or out of it? It's amazing that even a single image can raise so many questions. I'm guessing BepiColombo might be able to help us solve this puzzle.
Absolutely. By analyzing the composition and age of this lava flow, we might finally be able to determine its origin and how it relates to the formation of the Caloris Basin. Each image we get is like another piece of the puzzle falling into place.
This is why I love space exploration. It's like solving a giant cosmic mystery. Speaking of mysteries, there's something else about Mercury that I find really intriguing. It's actually quite a dark planet, right? I always imagined it as being super bright, given how close it is to the sun.
It's a common misconception. Despite being bathed in sunlight, Mercury's surface is surprisingly dark. It reflects less light than our own moon. It's something that has puzzled scientists for quite a while.
So what makes Mercury so dark? Is it the composition of the surface?
That's what we're trying to figure out. We know that the material beneath Mercury's surface is actually lighter in color. But something happens when it's exposed to the harsh conditions of space. Maybe interactions with solar wind or micrometeoroids. It's like the surface is slowly getting a cosmic tan, but instead of getting tannered, it's getting darker.
Interesting. So it's not just a static surface, it's constantly changing and reacting to the environment.
Right.
And I'm guessing these changes happen over incredibly long periods, right?
You got it. We're talking billions of years. But luckily, we have a few clues that help us understand this process. One of the key pieces of evidence is the contrast we see between younger and older features on Mercury's surface.
Okay, so what are we talking about here? What do these features look like?
We'll take the Neuther facula, for example. It's this incredibly bright patch on the surface. Imagine a giant splash of molten rock that has cooled and solidified. That's a facula. And because it's relatively young, it hasn't had as much time to darken.
So this facula is like a fresh splatter of paint on a canvas that's slowly fading over time.
Exactly. It's a prime example of how material from beneath the surface starts out lighter and then darkens as it's exposed to space. And then on the other hand, we have the Fontaine crater, which is another bright spot on the surface. But this one was formed by a relatively recent impact, so the debris hasn't had as much time to darken either.
It sounds like these craters are almost like time capsules, preserving snapshots of different periods in Mercury's history.
They really are.
Yeah.
And by studying the composition of these different features, both old and new, BepiColombo will help us solve the mystery of Mercury's darkness.
Okay, so we've got potential ice, ancient lava flows, massive impacts, and a surface that's literally changing color over time. Mercury is shaping up to be a lot more dynamic than I ever imagined.
It really is a fascinating little world, and we're only just scratching the surface.
Well, I'm definitely eager to hear more about these new images, but before we dive into the details, I think it would be helpful to get a better understanding of what these features actually look like. Could you paint us a picture of what we're seeing in these images? So starting with that bright Neuther facula.
Absolutely. So picture this. The Neuther facula is like a giant volcanic bullseye. At its center, there's this volcanic vent about 40 kilometers across, which was basically the conduit for this massive eruption. And surrounding this vent, you have a vast deposit of volcanic material. That extends outwards for at least 300 kilometers.
Wow, that's a pretty impressive volcanic explosion. And you mentioned that the brightness of the Neuther facula tells us it's a relatively young feature, right?
That's right. The Neuther facula is a perfect example of how volcanic activity can bring fresh, lighter-colored material to the surface, creating a stark contrast with the surrounding darker, older terrain.
It really highlights how dynamic and constantly changing planetary surfaces can be. What about the Fontaine crater? What's the visual on that?
The Fontaine crater is almost like a perfect circle stamped onto Mercury's surface. It's relatively small compared to some of the other features we've talked about. But what makes it stand out is its brightness. It's surrounded by this halo of bright material that was excavated during the impact.
So what we're seeing is basically the raw, fresh material from beneath the surface, which hasn't had time to darken yet.
Exactly. And that's what makes it so valuable for scientists. By studying the composition of this material, we can get a glimpse into what lies beneath Mercury's surface and how it's changed over time.
It's incredible how even something as seemingly simple as a crater can hold so much information about a planet's history.
It really is. And as BepiColombo continues its mission, we can expect to see even more incredible images and data that will help us piece together the complete story of Mercury's evolution.
I can't wait to see what other secrets this fascinating little planet holds.
Me neither. Every new flyby, and eventually the orbital data, brings us closer to understanding this enigmatic world.
Well, I'm definitely hooked. But before we wrap up this first part of our deep dive, I want to make sure we're all clear on the timeline for BepiColombo's mission.
Okay.
When can we expect the spacecraft to settle into orbit around Mercury and start sending back even more detailed data?
Great question. BepiColombo is scheduled to achieve orbit insertion around Mercury in late 2026. Once it's in orbit, it will begin a comprehensive science campaign using its suite of instruments to study Mercury's surface, interior atmosphere, and magnetic field in unprecedented detail.
So we have a couple of years to wait, but it sounds like the wait will be more than worth it.
I think so.
What are you personally most excited to learn from the orbital data?
Oh, that's a tough one. There's so many exciting possibilities. I'm particularly interested in learning more about Mercury's internal structure and composition. We know it has a surprisingly large iron core, but we don't fully understand how it formed or what its implications are for the planet's evolution.
It's like this giant metal mystery right at the heart of Mercury.
Exactly. And BepiColombo's instruments will be able to probe the planet's interior, giving us a much clearer picture of what lies beneath the surface.
It's incredible to think that we're on the verge of unlocking so many of Mercury's secrets.
I know.
But for now, we'll have to be patient and wait for BepiColombo to reach its destination. But in the meantime, these latest images from the 6th Flyby have given us a tantalizing glimpse of what's to come and raised some really intriguing questions.
They certainly have. And I think one of the most fascinating questions is this. If Mercury's surface darkens over time, does that mean the entire planet is slowly fading into darkness?
That's a great question. Is it just going to keep getting darker and darker? It makes me wonder if there's anything counteracting that process.
That's a really good point. If fresh material from beneath the surface is constantly being exposed through impacts and volcanic eruptions,
Right.
wouldn't that counteract the darkening to some extent?
That's true. It suggests there's a delicate balance at play between the darkening process and the exposure of new material.
Exactly. And understanding that balance will be key to unraveling the complex story of Mercury's surface evolution.
I'm already hooked, and I'm betting our listeners are too. We've covered so much ground already, but there's still so much more to explore.
I agree.
Let's take a quick break, and when we come back, we'll dive into even more detail about those icy craters at the North Pole, those vast volcanic plains, and that enigmatic Calorus Basin. Stay tuned.
All right, so let's get back to those icy craters at Mercury's North Pole. What's fascinating here is that these craters, they aren't just cold. They're some of the coldest places in the entire solar system.
Really?
This is because they're permanently shadowed, meaning sunlight never reaches their floors.
That's crazy to think about, especially considering Mercury is the closest planet to the sun.
Right.
It's like having a patch of the Arctic Circle right on the sun's doorstep. But I'm still trying to wrap my head around how ice could even last for billions of years. So close to the sun, wouldn't it just evaporate?
That's where the extreme cold comes in. These shadowed craters, they act like cosmic deep freezes. Even though Mercury has a very thin atmosphere, water molecules can still find their way to the surface. And in these incredibly cold craters, they can actually get trapped and accumulate as ice over billions of years.
So these craters are like time capsules, preserving ancient water ice that could hold clues about the early solar system.
Exactly. And BepiColombo is actually equipped with instruments that can analyze the composition of these potential ice deposits. We'll be able to determine if it's truly water ice and potentially even learn about its origin. We might even find organic molecules.
What?
The building blocks of life.
Finding water ice on Mercury would be huge. It could mean that water, a key ingredient for life as we know it, is more common in the solar system than we thought. And think about the implications for future space exploration. Maybe we could even use Mercury as a resource base someday.
Those are some very exciting possibilities. But for now, we need more data. Luckily, BepiColombo will give us a much clearer picture.
All right, I'm ready to move on to those vast volcanic plains we were talking about earlier. The Borealis Planitia is just massive, covering a huge portion of Mercury's northern hemisphere. I'm looking at the images, and it's just hard to grasp the sheer scale of it.
It really is a remarkable feature. Imagine a landscape completely reshaped by massive floods of molten rock. The Borealis Planitia gives us a glimpse into a time when volcanic activity dominated Mercury's surface.
It's amazing to think about that those plains were once a sea of molten rock, and we can even see evidence of those ancient eruptions in the images. You mentioned those partially flooded craters like Henri and Lismer, right?
Exactly. Those craters tell us that the lava flows were incredibly extensive and powerful. Imagine a crater slowly being submerged by a rising tide of lava. It must have been an incredible sight.
Whoa. It's like looking at a snapshot of a planetary apocalypse. And I'm still intrigued by those wrinkles on the surface. They almost look like stretch marks.
That's a great way to describe them. Remember how we talked about Mercury's interior cooling and contracting over billions of years? Well, those wrinkles are a direct result of that process. As the planet shrank, the surface buckled and folded, creating those distinctive patterns.
So those wrinkles are like a record of Mercury's shrinking process. It's mind-blowing how even subtle features can reveal so much about a planet's history.
Absolutely. And it all points to a period of intense geologic activity early in Mercury's life, a time when volcanoes ruled the surface erupting and reshaping the landscape.
It's amazing to think about how much change Mercury has gone through over billions of years, from a fiery volcanic world to the seemingly quiet planet we see today.
Indeed. And speaking of dramatic transformations, let's turn our attention to one of the most striking features on Mercury, the Caloris Basin.
Ah, yes, the granddaddy of all impact craters. This thing is absolutely massive, spanning over 1,500 kilometers. It's hard to wrap my head around something that big.
The Caloris Basin is a testament to the power of impacts in shaping planetary surfaces. Imagine a massive object, perhaps an asteroid or a comet, slamming into Mercury billions of years ago. The energy released during that impact must have been unimaginable.
The images really highlight the radiating troughs that emanate from the basin. They look like ripples spreading out from a pebble dropped in a pond, but on a colossal scale.
Those troughs are evidence of the immense shockwaves. Generated by the impact, they propagated through Mercury's crust, fracturing and deforming the surface for thousands of kilometers. It's like the planet itself was ringing like a bell after being struck.
It's incredible to think about the forces involved in an event like that. It makes you realize just how dynamic and chaotic the early solar system must have been. But within this massive impact zone, there's a feature that really caught my eye. It's this bright, boomerang-shaped lava flow. What's the story there?
You're talking about the mysterious lava flow near one of the large troughs, right?
Yeah.
It's a puzzle that has scientists scratching their heads. They're still debating whether this lava flowed into the basin after the impact, filling in the depression.
Yeah.
Or if it erupted from within the basin and flowed outward.
So did the lava flow into the Caloris Basin? Or out of it? It's like a cosmic whodunit with lava as the main suspect.
Well, there's evidence to support both theories. Some scientists think that the impact might have melted a portion of Mercury's mantle, creating a vast pool of lava that then flowed into the basin. Others believe that the impact might have fractured the crust, allowing pre-existing magma to erupt and flow outwards.
It's amazing how a single image can raise so many questions. BepiColombo might be the key to finally solving this mystery.
Absolutely. By analyzing the composition and age of this lava flow, we might be able to determine its origin and how it relates to the formation of the Caloris Basin. It's a reminder that even in the age of space exploration, there are still so many mysteries waiting to be unraveled.
Okay, so we've got potential ice, ancient lava flows, massive impacts, and now a mysterious lava flow that could rewrite the history of the Caloris Basin. Mercury is shaping up to be a lot more intriguing than I ever imagined. But before we get too carried away with the drama of these features, let's talk about something that might seem a bit less exciting at first.
Okay.
The darkness of Mercury's surface.
Ah, yes. The curious case of Mercury's darkness. It's a puzzle that has intrigued scientists for decades. Despite being so close to the sun, Mercury's surface is remarkably dark, reflecting less light than our own moon.
I have to admit, I'm still a little surprised by that. I always pictured Mercury as being this shiny, reflective world because of its proximity to the sun. What's going on there? Why is it so dark?
Well, it all comes down to something called space weathering. Imagine the surface of Mercury being bombarded by charged particles from the sun, micrometeoroids, and even cosmic rays. Over billions of years, this constant bombardment can alter the chemical composition of the surface material, making it darker. It's like the surface is being sandblasted on a cosmic scale.
So even though Mercury is bathed in sunlight, its surface is slowly being darkened by these weathering processes. It's like a cosmic tug of war between light and darkness.
Exactly. And one of the most compelling pieces of evidence for this darkening effect is the contrast we see between younger and older features on Mercury's surface. Remember the Nair Facula and the Fontaine crater?
Yes.
They both appear much brighter than the surrounding terrain because they haven't been exposed to space weathering for as long.
It's like comparing a brand new car to one that's been sitting out in the elements for years. The new car is shiny and bright, while the older car is dull and faded.
That's a great analogy, and it highlights how dynamic Mercury's surface truly is. It's constantly being reshaped by impacts, volcanic eruptions, and even these subtle weathering processes. It's not a static world, it's a planet in constant flux.
So it's not just a matter of what Mercury's made of, but how its surface interacts with the environment over time.
Right.
And this darkening effect isn't just a curious side note, is it? I'm guessing it has implications for how we understand Mercury's evolution as a planet.
You're right. Understanding space weathering is crucial for interpreting the data we get from spacecraft like BepiColombo. By studying the variations in brightness across Mercury's surface, we can get a sense of which features are older and which are younger. It's like a cosmic clock helping us to piece together the planet's history.
Wow, so it's not just about pretty pictures. It's about using these images to unravel the deep history of a planet. What are some of the other key takeaways about space weathering that our listeners should keep in mind?
Well, one important thing to remember is that space weathering isn't unique to Mercury. It's a process that affects all airless bodies in our solar system, from our own moon to asteroids and comets. It's a reminder that the universe is a dynamic and ever-changing place.
Okay, so it's a widespread phenomenon. Anything else?
Another key takeaway is that space weathering. It's a complex process that we're still trying to fully understand. There are many factors that can influence how a surface darkens over time, including the composition of the surface material, the intensity of the solar wind, and the frequency of micrometeoroid impacts.
It sounds like there's still a lot we don't know about space weathering. What are some of the big questions that scientists are still trying to answer?
Well, one of the big questions is exactly how different types of surface materials react to space weathering. We know that some materials darken more quickly than others, but we're still trying to figure out why. Another question is how space weathering affects the spectral properties of surfaces. You see, different minerals reflect and absorb light differently, and space weathering can alter these spectral signatures.
So it's not just about how dark the surface is, but also about how the colors and wavelengths of light are affected by space weathering.
Exactly. And by studying these spectral changes, we can get clues about the composition of the surface material and how it's been altered over time. It's like forensic science, but on a planetary scale.
This is all fascinating stuff. I'm starting to see how something as seemingly simple as the darkness of a planet's surface can open up a whole new window into its history and evolution.
Absolutely. And that's what makes studying Mercury so exciting. Every new piece of information we get challenges our assumptions and pushes us to rethink our understanding of this fascinating little world.
Okay, so we've talked about icy craters, volcanic plains, massive impact craters, and even the mysterious darkness of Mercury's surface. I'm already feeling like I've learned so much.
Me too.
But there's one more topic I want to touch on before we wrap up this part of our deep dive. Something that I think a lot of our listeners might be wondering about.
Yeah.
If Mercury is so close to the sun, how hot does it actually get? I mean, we're talking about a planet that's practically skimming the surface of a star.
You're right. That's a great question. And the answer might surprise you. Mercury doesn't have a thick atmosphere to trap heat, so its surface temperature can fluctuate wildly between day and night.
So it's not a constant inferno.
Not at all.
That's interesting.
On the side of Mercury facing the sun, temperatures can soar to a scorching 430 degrees Celsius, hot enough to melt lead.
Wow. That's definitely hot enough to fry an egg, or maybe even a whole chicken.
But on the night side of Mercury, temperatures plummet to a frigid negative 180 degrees Celsius. That's colder than the coldest temperatures ever recorded on Earth.
Okay, so we're talking about a planet with some serious temperature swings. From scorching hot to freezing cold, all within the same day. That's a pretty extreme environment.
It certainly is. And it makes you appreciate just how resilient life has to be to survive in such harsh conditions.
So we've got ice, we've got volcanoes, we've got massive impact craters, we've got space weathering, and we've got extreme temperature swings. Mercury is proving to be a planet full of surprises.
It really is.
But before we move on, is there anything else you want to add about the temperatures on Mercury?
Well, it's worth mentioning that these extreme temperatures, they also play a role in shaping Mercury's surface, the constant expansion and contraction of the surface material. Due to these temperature swings, can cause fracturing and faulting, contributing to the planet's wrinkled appearance.
So the wrinkles aren't just from the planet shrinking over time. They're also influenced by these daily temperature extremes. It's like the surface of Mercury is constantly being stretched and squeezed.
Exactly. And that constant stress can lead to the formation of new features, such as cracks, ridges, and even small scarps.
It's amazing to think that something as simple as temperature can play such a significant role in shaping the surface of a planet.
Absolutely. And it's a reminder that even seemingly small factors can have a profound impact over billions of years.
Okay, so we've covered a lot of ground in this part of our deep dive. We've explored icy craters, vast volcanic plains, massive impact craters, the mystery of Mercury's darkness, and even the extreme temperatures on this fascinating little world. But there's still so much more to discover.
I agree.
After a quick break, we'll delve into even more detail about what these new images from BepiColombo are telling us about Mercury's past, present, and future. Stay with us.
All right, we are back and ready to wrap up our deep dive into the latest from Mercury. We've covered so much ground already, from those icy craters hiding in permanent shadow to those vast volcanic plains that hint at a fiery past. It's clear that Mercury is a planet of extremes, full of surprises. Absolutely.
Yeah.
And what's so exciting is that we're only just beginning to understand this fascinating little world. Every new mission, every new image brings us closer to unraveling its secrets.
And these latest images from BepiColombo's sixth flyby have definitely given us a lot to think about. We've talked about the possibility of water ice, the evidence of ancient volcanic activity, the colossal Calorus Basin, and even the mystery of Mercury's dark surface. It's amazing how much information we can glean from just a handful of pictures.
It really is remarkable, and it's a testament to the ingenuity of the scientists and engineers who designed and built BepiColombo. This mission is equipped with cutting-edge instruments that allow us to see Mercury in ways we never could before.
I'm curious, what are some of the key things that you as a scientist are hoping to learn from BepiColombo once it's finally in orbit around Mercury?
Well, one of the big mysteries I'm hoping we can solve is the origin of Mercury's magnetic field. It's surprisingly strong for such a small planet, and we're not entirely sure how it's generated. Some scientists think it might be related to the planet's large iron core, but we need more data to confirm that.
So it's like this giant magnetic puzzle at the heart of Mercury.
Exactly. And BepiColombo will be able to map Mercury's magnetic field in unprecedented detail, giving us a much clearer picture of how it works and where it comes from.
It sounds like there's still so much we don't know about Mercury's interior. I'm also really intrigued by the possibility of finding more evidence of past volcanic activity.
Oh, me too. We've already seen evidence of extensive lava flows in the Borealis Planitia, but I'm hoping BepiColombo will help us to pinpoint the locations of ancient volcanoes and maybe even identify different types of volcanic eruptions that occurred on Mercury.
It would be amazing to get a glimpse into what those eruptions might have looked like. I can just imagine fountains of molten rock spewing into the sky and rivers of lava flowing across the surface.
It must have been a truly spectacular sight. And who knows, maybe we'll even find evidence of more recent volcanic activity. Some scientists believe that Mercury might still be volcanically active today, although at a much lower level than in the past.
That would be incredible. It would mean that Mercury is still a dynamic and evolving world, even after billions of years.
Exactly. And it would make Mercury even more fascinating to study.
Okay, I'm definitely sold. Mercury is officially on my list of must-see destinations in the solar system. But let's be realistic. I'm not going to be hopping on a spaceship anytime soon. So for those of us who are stuck here on Earth, what's the best way to stay up to date on the latest discoveries from BepiColombo?
Well, the European Space Agency and the Japanese Aerospace Exploration Agency have fantastic websites with tons of information about the mission, including images, videos, and news updates. And of course, there are plenty of great science magazines and websites that cover space exploration. So keep an eye out for articles about BepiColombo.
Great advice. I'm already feeling inspired to do some more research. But before we wrap up, I want to leave our listeners with one final thought.
Okay.
We've explored ice volcanoes, impacts, and even the mysterious darkness of Mercury. What do you think is the most important takeaway from these new images? What should our listeners be thinking about as we await more data from BepiColombo?
That's a great question. I think the most important takeaway is that Mercury is a much more complex and dynamic world than we ever imagined. It's a planet of extremes with a rich history and a fascinating story to tell. And as we continue to explore it, I'm sure it will continue to surprise us in countless ways.
Well said. So for our listeners who are now just as captivated by Mercury as we are, what's one thing they should keep in mind as we await more data from BepiColombo?
I'd say keep an open mind. Mercury has already surprised us in countless ways, and I'm sure it has many more surprises in store. Don't be afraid to challenge your assumptions and embrace the unexpected.
I love that. Embrace the unexpected. After all, it's the unexpected discoveries that often lead to the most profound insight.
Exactly. And who knows, maybe one of our listeners will be the one to make the next groundbreaking discovery about Mercury.
Now that's an inspiring thought. Well, expert speaker, this has been an absolutely fascinating deep dive into the latest from Mercury. Thanks for joining us and sharing your expertise.
It's been my pleasure. Always happy to talk about the wonders of our solar system.
And to our listeners, thank you for joining us on this journey of discovery. Until next time, keep exploring, keep questioning, and keep looking up at the stars.